Greetings. My presentation will be on Bathynomus giganteus. It is a species of giant isopod. I will be looking at first some general facts about giant isopods so we can learn more about them, and then I will dive into a study that intends to learn specific information about them, and I'll talk about that study at length. Here's the classification of the giant isopods. As we can see, there are arthropods of the class Mellicostra, so they belong in the same class as crabs, lobsters, and shrimp. These are isopods, so they are related as well to like the roly-poly bugs that you would see on land as well. And then the Bathynomus is this genus of the giant isopods, and I'm going to be focusing more specifically on the species of Giganteus. Moving along into some features and characteristics, their shells, they have two varieties of color, brown and pale lilac. The uropods are the two little fins at the end toward the right on the top picture. They're just like little flappers. They're like fans for the tail that allow it to swim easier. The plesiopods, those are the little like swimlets all around like the body. And those just aid in swimming as well. They kind of like glide around on the bottom, kind of using their legs, but also like flapping the uropods and the plesiopods to swim. They have 4 sets of jaws. They are very small, but they are very powerful. They have large compound eyes with over 4,000 facets, but being bottom dwellers, they still do not see very well in the dark. They do have something in common with cats. They do have what's called a tapetum, which is a reflective layer in the back of the eye that's supposed to help see in dark spaces. But again, they don't see very well. They use their antenna more. They have 2 sets of antennae. So one is for chemical reception, so it has chemoreceptors, and then the other one is more for something physical location, so it has a bunch of tactile sensors. These isopods have 7 pairs of legs as well. Bathynomus giganteus is the largest known species of giant isopod. The adults average about 30 centimeters and 4 pounds, but the largest ones are over 40 centimeters, which is over 16 inches. So why these isopods got so big is through a phenomenon called deep sea gigantism, and this can kind of be explained through 2 rules. So first is Kleber's rule, and Kleber's rule states that larger animals are more efficient than smaller animals at spending energy. So this has to do with the surface area to volume ratio as it relates to heat dissipation. So because the animals are larger, their volume to surface area ratio favors volume more, so that they don't lose as much heat through the outside of their body as a smaller animal would, and thus they don't have to have a high of a metabolism to be as large. And then Bergmann's rule, this is a little bit more debated throughout the year, and just because it's not had as much empirical evidence, but it tries to explain the phenomenon. And this states that organisms tend to increase in body size corresponding with a decrease in temperature. So this kind of goes along with the same thing about losing heat dissipation. There are 20 living species of Bathynomus, as I said, Giganteus being the large. An interesting fact about isopods is they all have gills to breathe. So even the ones living on land still have gills, but they need to be kept in a moist environment. That's why they're burrowing in the ground so much, and the giant isopods have evolved to live completely underwater. Another interesting fact is they curl up when threatened, like the pill bugs on land, and this is to protect the soft tissue of their underbelly. So looking at some sex differences in reproduction, the giant isopods do not have a larval stage. When they hatch from their eggs, they look very similar to their parents. One of the only things is they're missing their 7th parapods, which are their legs, and those tend to grow on later with the coming of sexual maturity. As with all crustaceans, they molt to grow, and they continue to grow throughout their life. So looking at the females actually lay the largest eggs of all marine invertebrates, which they're over half an inch in diameter. They also have a brood pouch like kangaroos, so they'll actually keep their young in there after they hatch to care for them. The females also bury themselves when they're brooding, so they'll basically just dig themselves in a hole and stay there from anywhere for a week to up to a month or two when they're brooding their young. The males have 2 penis that carry the sperm, and they inject the female anywhere, and then the sperm will migrate to the ovaries. This is usually done after molting, as the female is a lot softer than she normally would be. The giant isopods feed on what's called food fall, which is basically just any large organism that dies and then falls to the bottom of the ocean. They're going to eat that up. What's interesting is they only average about 1 to 3 meals per year, as food falls aren't very common, especially in the deep ocean. These organisms have an incredible ability to go without eating for long periods of time, as some in captivity have fasted for up to 5 years. They're going off the picture on the bottom, the isopod going on strike. There was one isopod in Japan that actually gained some national attention due to it not eating for so long. So people came and watched all around, and it was kind of getting attention because it was like, oh, is this the day that it's going to eat or is it not? And it ended up going for 5 years without eating. And it would even fake that it was eating just to please the aquarium eaters. It did end up dying. They don't know why, if it was sick or just stubborn, but it was a mystery. As I said before, the isopods use chemoreceptors in their antennae to find food. And they live in semi-hibernation, so their metabolism is very slow, and most of the time they're not fully conscious. They just kind of roam about on the bottom, and this is so that they can preserve as much energy as possible. So like I said, the food falls are rare, so when they do happen, these isopods gorge themselves lots of times up until the point where they have very limited movement, if they even can move afterwards at all, as these organisms have great energy stores, lots of fats, carbs, and lipids available in their bodies so that they can go for so long without eating. The picture on the left was actually done by the University of Louisiana. They dropped an alligator to the bottom, and they were curious to see as if the isopods would eat this, as it's not normally their meal. They were curious about if they were able to eat through the tough hide of the alligator, but it eventually proved easy chewing for them. As I said before, the giant isopods are bottom dwellers. They spend most of their time on the bottom of the seafloor roaming about. These can be found around 250 to 1,000 meters deep, and in the deeper depths it can be over 1,000 psi, which is crazy. These are found mostly within the tropics, so mostly within the latitudes of 30 degrees north and 30 degrees south. And the water temps at the bottom are anywhere from 1 to 10 degrees Celsius, so it is very cold. You can find them in the American continental slope, so like off the coast of Florida and Georgia, as well as around the Gulf of Mexico. They are found in the Northwest Indian Ocean as well as the Northwest Pacific near Taiwan. And what scientists found is these are all very similar around the world, so this indicates a lack of evolution throughout the isopods, and it seems like they're doing very well for themselves. So now I'm going to introduce a little bit about the study that I wanted to analyze in depth. The goals of the study was to compare the seasonal movements of the giant isopods, analyze their sex ratio and reproductive period, estimate the growth curves, longevity, and mortality, as well as evaluate the risk of extinction for the giant isopods. They looked at 2 species, with Bathynomus giganteus being one of those. The study area was off the southern coast of Brazil, as we can see from the map, and they took samples from depths of 200 to 1,000 meters deep. They left traps. They had 5 journeys that they took out there through the course of 3 years, or 2 years, excuse me, and they left the traps for the isopods, and then once they pulled them up, they analyzed and sexed them. They grouped them into 6 categories: the manca, which is the youngest of all of them, the juvenile, and then the immature males and females. The chart above kind of explains some of the sex differences and what they looked for in determining between the manca and the juveniles, as well as what determines the male or the mature and immature males and females. Some were anesthetized and preserved in ethanol as well for further study later on. Here are the results of the identification. In total, they found 663 of Bathynomus giganteus. What they found was there was fairly equal across sex ratio, across seasons, latitudes, and depths. They did find that there were slightly more males in autumn and slightly more females in winter, as well as that they often found younger, smaller creatures at greater depths away from the shore, which was interesting. They did find ovigerous females year-round, so this disproves the fact of like a mating season, so the isopods will reproduce year-round. They also made sexual maturity estimations as to what size do we find that most of our isopods are sexually mature. They also found that maturity occurred during the 2nd year of life for most of the isopods. So the study also looked at the growth rates. They can be seen at the bottom in the 2 charts for males and females. The smallest isopod was a manca, and it was 50 millimeters, and the largest isopod they found was a mature male at 405 millimeters. The largest giant isopod in the world was 425 millimeters, so they actually came fairly close to that mark. There was one group that claimed to have a giant isopod over 500 millimeters, but this was never confirmed. I suspect that perhaps there will be some that get that big, but we just haven't found them yet. As with a lot of deep sea creatures, we don't know much about them as we do our land creatures. So they also looked at the longevity, which they defined as the time to reach 95% of the asymptomatic length. So for males, this was 6 years, and for females, this was 7.5 years. Unfortunately, they calculated the mortality of capture between 50 and 100% for this experiment. So the last goal of the study then was to evaluate the risk of extinction. They deemed this as of least concern. This was due to the species having such a large area of habitat and a fairly short generation length that they had a minimal risk of extinction. There was initially concern about this because they are caught as bycatch from the fishing industry a fair amount, but this proved to be not a significant threat. Plastic pollution, however, is still an ongoing problem. There have been studies that have found plastic particles in the digestive system of giant isopods, and that can pose a risk to their health. So what areas in Asia have done, they've actually made the giant isopod sort of like a flagship animal for conservation, similar to what they've done for like pandas and sea turtles. So it's not uncommon in areas like China and Japan to see giant isopod phone cases. So many kids over there will know what giant isopods are, whereas I don't think many American kids would know what giant isopods are. They also make stuffed giant isopod animals. They're like plush. You can buy them off of Amazon. And this has all helped to spread awareness about these creatures. They've also made an appearance in the meme world. Someone staged these isopods around a bag of Doritos, and someone was very confused what they were, but this meme gained some rather large attention and helped spread awareness about these creatures to help conserve them. Here are my works cited. Thank you very much for listening.